Good evening, and welcome to the American Meteorological Society's third ever Science is for Everyone webinar. My name is Tiffany Risch, and I will be your AMS facilitator for the next 60 to 70 minutes. I'm looking forward to tonight's program. Thank you for spending a bit of your evening with us. The American Meteorological Society, or AMS for short, is a global community committed to advancing weather, water, and climate science and service. The AMS strengthens the weather, water, and climate community by helping policymakers and scientists understand one another and work together more effectively. AMS also supports kindergarten through high school educators, as well as faculty and students at colleges and universities. Of equal importance is the dedication of AMS to conducting public outreach, such as our Science is for Everyone webinar this evening. Science is for Everyone is a brand new series of innovative educational opportunities designed to improve the scientific literacy of community members across the globe. Tonight's presentations are offered virtually by way of a webinar. In future events, learning will be from a hybrid platform, part virtual and part in person, with both small and large groups, and including some interactive activities. Let's take a moment to go over some administrative notes for tonight. Please ensure that you're muted so that we don't hear any of your side conversations. Also, to help with internet connection, please turn off your video as well. If you have any questions, please feel free to type them into the chat box below. I will be monitoring the chat box throughout the presentations. In addition, if you have any technical issues, we do have a representative from our tech team that's available to help. Tonight's format includes a celebrity guest host and 2 exceptional presenters. Each presentation is about 20 minutes, which includes a period for questions and answers. In between the 2 presentations, we have several poll questions, and at the conclusion of tonight's event, we will post a link in the chat box to a post-webinar survey. We also will email the link to you at the address you provided during your registration. Your feedback is so important to the success of our future Science is for Everyone seminars. We welcome any and all comments and suggestions. Tonight's presentations focus on the air you breathe. We'll hear about air quality challenges in and around Houston that are unique and dynamic as the city itself. We'll also learn about how air quality is monitored in innovative ways. Every time we have a Science is for Everyone event, we will pick a host city. Houston, Texas is our host city for tonight's program. That's why one of our presentations is Houston specific. Guest hosts will also come from the host city. Our speakers will come from all locations. At this point, are there any questions? If you have them, type them in the chat. I'll take a look and see if we have any. I don't see any down below. Feel free though throughout the presentation if you'd like to. Let's now continue with a short welcome video from the AMS president, Mike Farrar. If this is the second night that you're joining us, you've already heard from our president. However, we believe his welcome is good enough to hear twice. If this is the third time that we've seen you this week, first of all, thanks so much. And secondly, if you need to take a bio break, we understand.
Well, thank you very much. I really appreciate that kind introduction. As you now know, my name is Mike Farrar, and I've had the privilege of serving as president of the American Meteorological Society, or the AMS, for the past year. In that capacity, I've traveled and met many individuals from all walks of life. One thing I can say is that science is becoming a larger part of everyday living than ever before. Scientific knowledge helps people to be better informed so as to cope more effectively with the societal challenges and to make the best decisions for themselves, their families, and their communities. Supporting the public in becoming more scientifically literate is an obligation of organizations such as the AMS. The AMS is a global community committed to advancing weather, water, and climate science and service. And to that end, our Board on Outreach and Informal Education is beginning a multi-year endeavor to reach out to all audiences and provide quality science learning opportunities. This week, we're kicking off our Sciences for Everyone educational series with 3 evening webinars during our annual meeting in the great city of Houston. The presentations feature topics chosen by Houston community members. They include flooding, extreme temperatures, and air quality. Of course, these topics are also of interest to other communities across the globe. Unlike a seminar or more technical presentations, which are filled with science speak and cryptic terms, our Sciences for Everyone series is designed with you in mind. So who is you? Anyone and everyone. From science novice to science enthusiast, we know you will all enjoy our speakers and guest hosts, and more importantly, you will learn about science. So thank you once again for joining us for our inaugural webinar. We hope you will continue to be our guests throughout the year and for other learning opportunities.
You can see that the AMS is serious about outreach. Our thanks to Mike for recording that video.
All right, hello everybody. I'm David Tillman. I'm a meteorologist at ABC 13 here in Houston, Texas. I guess the host city for this year's AMS conference, and I'm glad to be here.
David, can I actually tell our audience a little bit about you, if you don't mind?
Yeah,
okay?
Go right ahead. Go right
ahead.
Awesome. Share away.
Awesome. Great. So after graduating from Jackson State University in Jackson, Mississippi with a Bachelor of Science degree in meteorology, David Tillman began his broadcast career. He was the weekend meteorologist at WAPT-TV in Jackson. A year later, he worked for the National Weather Network during the weekends and produced weather segments for 35 television stations and 45 radio stations across the United States. David then found himself in Memphis, Tennessee at WMC-TV. He worked there as the station's meteorologist and received an Emmy Award for his coverage of a snowstorm that hit that city. In late 2000, David moved to Houston and ABC 13. He is the chief forecaster in Houston. David is a member of the American Meteorological Society and of the National Weather Association. In 1998, he received his seals of approval from both organizations. Born in St. Louis, David and his wife, Patricia, have 3 children, David, Brianna, and Sydney. And David, I have to say welcome. And you know, I've never shared the screen here with an Emmy Award winner, so congratulations. You know, I'm marveled at, it has to be amazing the work that you must have done in order to receive that award.
Well, thank you. And I'm glad to be here. Yeah, I did a little work to get that particular one. When I was in Jackson and Memphis, it was all about tornadoes, and every now and then we'd get a winter storm. But when I came to Houston, it began to be about different things, hurricanes and floods, but it also started to be about air quality as well, because as you know, Houston is one of the industrial giants in the United States, and the petrochemical complex here in Houston is just enormous and very significant. So I had to cover, you know, flooding and tornadoes and hurricanes and things like that, but I had to give some serious thought to what was happening with air quality as well. And that's why I'm glad that we're talking about this tonight. So thank you, Tiffany, for that. And what I'd like to do here is go ahead and introduce to you our first speaker, and his name is Doug Boyer. Doug Boyer is an atmospheric scientist who has spent 20 plus years of experience, analyzing and modeling air quality with the Texas Commission on Environmental Quality. He's a proud husband, playground wrangler of 2 kiddos, and a climber of rocks. And Doug, welcome to our program this evening. And you're a parent just like I am. I just want to tell you a little something brief about myself as well, and that I guess I'm a little strange in that I typically am not cognizant of being, you know, having a problem with air quality, or at least I don't believe I do, but almost everybody around me can sense every little change in the weather and every little change in the air quality as well. And I'm sure you've got some really important information to tell us all about how we go about collecting this information and keeping everybody safe.
Well, yeah, thanks a lot for that introduction. Let me bring up my presentation here. Okay. Hopefully everybody can see that now. Tiffany, can you let me know if you can see that?
I can.
Okay, great. Yeah, thanks for the introduction, David. Yeah, you and I share getting to Texas about the same time in late 2000, and I've really enjoyed my time. Probably overshot the getting to a warmer climate. I came from Michigan, and it's pretty warm here in the summer. Anywho, yeah, thanks for that introduction, and good afternoon, evening, everyone. My name is Doug Boyer, and I am with the Texas Commission on Environmental Quality. That's the state of Texas's environmental regulatory agency. And I'm just going to have a discussion about air quality today, why it's important, what the air quality data is that we collect, and how that's used in some of the policy decisions and research. So in that, just quickly going to have a background on air quality, and again, what we do at TCEQ and how that's used. And then I'll dive into Houston and its ozone issues and some of the air quality research that's going on there. So why are we concerned with air quality? You know, it's really about our health and that of the environment. And so pollutants in our air can increase the amount or severity of disease. And you've probably heard of asthma and even lung cancer. So children and elderly folks are generally more affected, or those that have some already existing health conditions. Also, wildlife, crops, our water and soil can be impacted by air quality or by the pollutants that are in the air. So for example, the image in the top right shows that trees, they can be injured by elevated ozone pollution. So to address those concerns, we have health-based standards for our common air pollutants. And there's six main ones there: ground level ozone, particulate matter, nitrogen dioxide, sulfur dioxide, carbon monoxide, and lead. And you've probably heard of some of these, and a lot of them are formed through the combustion of fuels. There's also hazardous air pollutants or toxics, and those can have some more acute effects. You've probably heard of benzene or mercury. And so these are all pollutants of concern that we have. So we know that air quality is important, and but where do these pollutants come from? And if we understand more about that, perhaps that we can do some things to address that air quality concern. So generally, air pollution comes from our everyday activity, our travel, certainly cars, trucks, planes, trains, and ships, our industrial facilities that provide us with electricity or goods, our agricultural activities, oil and gas exploration, just anything that we do generally in our cities. Having a paint can in the garage can produce emissions of pollutants. And there's also natural sources as well, like the Tonga volcano that just occurred, and there's wildfire emissions as well that can cause some concern for our health. So as we move forward, we want to figure out, okay, we know those are concerns and sources for us, but then how do we take that into account and measure it and compare it back to those health-based standards? So the image on the top left there shows one of the TCEQ trailers that would house instruments to detect some of those common air pollutants. And so the instruments inside would pull in air, and then determine what the concentration is and determine if the air is meeting standards or not. So Texas is a big state, and it has about 200 of these surface monitoring stations. About 150 of them are operated by TCEQ or the state of Texas. Others are operated by universities or local governments, industry, and other groups. And so there's other networks out there as well of instruments, and you may have heard of sensors, and these are ones that you could purchase yourself and install in your yard or on the side of your house or apartment. And there are ways for you to check how the air quality is in your area. I listed a couple of resources there, both from the EPA and TCEQ, where you can go and get more data on the air quality in your area. So that's how we typically measure air quality, but there's other methods as well. We know that pollutants don't always just go right over a stationary ground monitor. So we monitor air quality for regulatory and research purposes and with other methods. And so at TCEQ, we have mobile monitoring bands that can go out and be deployed for like an emergency response type situation. We're investigating the use of drones right now, and we've put monitors on different types of aircraft, ships. We put them on balloons as well to see what pollutants are like vertically in the atmosphere, and also use partners like the University of Houston and their mobile monitoring laboratories. So many ways to get data, but then, well, what do we do with that data? How is air quality data used at TCEQ, or the State Environmental Regulatory Agency? The main one is to determine compliance with the health-based standards. So is the area that you're living in, is it meeting that standard? And doing that, we analyze trends as well, trying to see when and where these patterns exist. Are high levels likely only at certain times of the year, different seasons, or maybe just in a specific part of the day? We definitely look at elevated concentrations that occur during specific days or maybe multi-day events. And we want to understand more about those and understand if was it locally generated or was some part of it transported in, say from a wildfire further away. And then we like to also look at how that reflects back on a past event. And were the weather and the emission conditions similar, or were they very different? And that helps us understand how we can possibly control that. So all of this data and how we look at it helps evaluate our regulatory requirements that we have, and hopefully that will improve air quality. So now I'm going to dig into a specific pollutant, and that some areas in Texas have had challenges with this, and it's ground level ozone. And lots of urban areas within the country have a challenge with that. So specifically, ozone, it's a pollutant that's formed in the atmosphere. So it's not directly emitted from a tailpipe or a stack. And so we have emissions, pollutants of nitrogen oxides, and these come from combustion sources when we're burning fuels, and then volatile organic compounds. These are pollutants from like gasoline vapors or solvents. And when those combine in the air in the presence of sunlight, so during the day, they can form ozone. And in Texas, our Texas heat, that can sort of make this reaction happen quicker and make it more efficient. And so more ozone can form. So ozone is a component of smog, and it's a lung irritant, and that's why we're concerned about it. So it can cause breathing problems like asthma, like we talked about before. So in Texas, we have some areas that are of concern, and this bar chart here shows the different areas of the state, the different urban areas going up and down there. And then going across, we have the different, the ozone concentration, and we're going to compare it to these health-based standards. And the values don't specifically matter here, but when we look at the blue bars, those indicate that a lot of our areas within Texas, they meet that ozone health standard, and that's great. But we still have challenges, and the top 4 bars indicated in red are the Houston area, Dallas-Fort Worth, El Paso, and the San Antonio area. So they still have remaining challenges with the health-based standard, and things are improving, but we still have more to go. So we have some areas that don't meet that standard. And so what happens then? And the figure on the right shows the different areas within Texas that don't meet specific standards, and we call those non-attainment areas. But if an area doesn't meet that health-based standard, the state is required to develop a plan to say, hey, okay, this is how we're going to move forward and improve air quality and try and meet that standard by a certain date. And in there, we want to analyze data, and we want to determine why is that challenge there? What is causing the, in this case, ozone pollution in Houston? And what are the sources, and what are the concerns that we have? And so we do that. We also have to inventory every source of emission that's possible out there. And so we want to know where all the gas stations are, where all the power plants are, how often you're driving your car, all the things that are out there as possible that we can get. Some things that would be in the plan may be permitting changes. And so when a source wants to start up, or a new facility wants to start up, or one wants to make a major change, it might have to reduce more emissions than they would come in with. And so that's a benefit to air quality. We also might have to predict what's going to happen in the future. And the way that we do that is with advanced computer modeling, taking into account chemistry, all the emission sources we talked about, and the weather. And then if we still think that the area is going to have some challenges remaining, there may be rules that the state would propose. And so that might include emission reductions from certain categories of sources. Okay, now we'll go into a little bit more about Houston. And so some specific facts about Houston, like David talked about, it's a big city, and it's a big urban city, the 4th biggest in the country, and it's the largest in terms of geographic size. There's a lot of people and all their normal activities, but then there's this industrial part that comes with the 2nd or 1st busiest port that's in the country. A lot of those, the petrochemical and refining capabilities too. So there's sort of like a dichotomy of these 2 big parts of Houston. And then we have a lot of forests. That's part of the natural part of the emissions that are there. And then it's on the coast, and there's really unique weather that comes with being on the coast. And it's part of this where winds will blow offshore at night and then recirculate back during the day. And that can cause some real air quality challenges. They're unique characteristics, and what happens is that it attracts scientists too. And so I've been lucky to be part of that. You'll hear from Laura later about this and other folks. So in that, I wanted to show a trend in air quality for Houston. And this is the past 30 years of ozone pollution data for Houston. And the red line is that concentration value over time. And it starts at 124 parts per billion. That's just the concentration unit in 1991, and it is down near 77, close to those health-based standards that we're concerned about. So, and since 2000, we've had over a 30% decrease in the ozone pollution in the Houston area. And that's great. And that comes at the same time that population in the area has increased by 50%. So 50% more people have come in with all their normal activities, but yet air quality has been improving. So that's a great success story. And part of this trend too is the air quality research that's going on. And so I wanted to talk quickly about some air quality field studies that have come in with a lot more monitoring. And in 2000 and 2006, there was some researchers came in with the state of Texas and found that there were some specific chemicals called ethylene and propylene that are involved with plastics manufacturing and chemical refining. And those were found in a lot higher concentrations than were thought to be there. And that really increased the amount of ozone formed in the area. And so the results of that were that there was some rules and partnerships with industry to reduce those chemicals and to reduce the pollution. And that brought ozone concentrations down at the same time. Now in 2013, there was the Discover AQ campaign that came in with NASA, and they really helped us understand how ozone and other pollutants are transported around in the area and coming from farther away and then mixing around. And that's helped us understand how we can continue to improve upon air quality in Texas. Now, just in this past year, we had another air quality study, and that was called Tracer AQ. And there was a whole lot of folks came in, NASA, many universities, and TCEQ were involved. And we just wrapped up this campaign in September. And one of the things that we really wanted to look at was, I talked about this coastal weather part. And so we had found in some of our previous research that some of the pollution comes off of the Houston area and goes into, this is Galveston Bay and offshore, and then it can sort of cook in this weird atmosphere that's over the water and then come back into the urban area and cause some air quality concern. And so we instrumented some boats, and those were out there taking measurements. And at the same time, we had some unique platforms on land, and then a NASA aircraft that was mapping the pollution at the same time. And so we're really excited about the results of this, and we'll be studying this data for a while, but hopefully this will continue to improve the research and science to help us reduce our ozone pollution further as time goes on. So quickly, the last thing I wanted to say is that we're continuing on with air quality research at TCEQ, and we fund projects internally to universities and private institutions to try and advance our understanding of air quality. And there's another program that's administered by the University of Texas at Austin called the Texas Air Quality Research Program. It's funded every single time someone registers a vehicle in the state of Texas. And they're also looking at air quality research to help improve our understanding and move public policy forward. So with that, I really appreciate everyone's interest and time today. And if anyone has any questions, I'd be happy to take them.
Okay, and Tiffany, I'm having some problems with my mouse here. If you are monitoring the chat, is there anything in the chat? I have some questions to ask Doug if there isn't, but you see any questions in the chat that anybody's wondering about?
Sure. Well, if you want to go ahead and ask your questions first, I do have one of personal interest here, but go ahead and ask yours. Go ahead.
Okay, so Doug, I heard you mentioned ozone just a little while ago, and a lot of people might get the different types of ozone confused with each other. Like you were talking about ground level ozone, and then we hear all the time about the ozone layer, if you will. Can you explain to people what's the difference between ground level ozone and the ozone layer, and which one is good and which one's bad?
Right. Yeah. So that's a very good question. Ground level ozone is down where we're breathing, and the ozone layer is many kilometers above us, and that helps. In that case, the ozone is good, and it's protecting us from the harmful rays of the sun. And so there's definitely differences in where they're located, but the chemical is still the same. I hope that answers the question.
Yeah, and I guess another one, maybe you can answer this, maybe not. I heard you mention something about sunlight is a necessary component to get the, to get the ground level ozone going. How does that happen?
Right. So it's unique in that we need the sun's rays there to help break apart some of the those chemicals, and that helps start this chemical reaction that then will form ozone concentration. So it's breaking up those nitrogen oxides and the volatile organic compounds into other things that then will form ozone. So it gets into some pretty detailed atmospheric chemistry. Yeah.
All right, and I've got another one here. Recently we've been talking a lot about Saharan dust. We get into this Saharan dust season here in Houston, and you get this dust that comes all the way across the Atlantic Ocean, and I used to kind of write it off because I'm not really affected by it, it seems, but a lot of people are truly affected by Saharan dust when it shows up. How does Saharan dust compare to other types of irritants, pollution-wise, that we might encounter here in Houston?
Saharan dust is part of particulate matter for sure, and so that is a concern and a health concern. So particulate matter can go down into our lungs and cause issues. I see someone's talking about allergies there, and so we have noticed that some people are more susceptible or allergic to that type of thing. I don't know if it's the largest concern for, say, the Houston area. The ozone concentrations could be more of a concern. Particulate matter at times, especially maybe not from Saharan dust, but it does change some of our air quality patterns, I guess, and we always look at where things come from. So it's always a unique research topic for Saharan dust. And we also know that Saharan dust, those times reduce the likelihood of tropical storm formation. So that falls more within, I think, some of your work, right?
That's exactly right. And I've got another question here, and it has to do with some of the things that happen here in Houston at the TV station here. You can go from a completely quiet news day to there being a major problem if there should happen to be some accident that happens at one of our plants, okay? And so there's always this lag in time between when we know that, this is a problem for the public or not. There's always that lag. What do you suggest people do in that period of time before we know for sure that this is an issue?
Wow. Well, I'm not a public health expert, so it's hard for me to answer that. But people's personal safety is definitely something they should be aware about. And I think each of those events is so unique that I'm not able to answer that one really well.
All right, Tiffany, you had a question?
I did. So Doug, during the pandemic, I've heard on the news and through various outlets that we saw differences in our ozone because people were staying home, factories were being shut. Is that true? Did we see changes in the ozone?
We saw changes in some pollutants, and that happened generally during the first part, I'll say, of 2020, when we had a little bit more people staying home and lockdowns. But a lot of that was just normal everyday traffic from people. And then that seemed to pick up pretty quickly. And we didn't really see much of an impact later in 2020 and 2021. So things like movement of goods, trucks, even aircraft traffic was still pretty normal for that type of behavior.
Thanks.
All right, and let's keep it going here with you, if you don't mind, Doug, for a few more minutes.
Sure.
You talked about the different types of things that could affect us here in the Houston area. Do you have any statistics or just have a feel for which one of these more often than others gives people problems? What sends them into, a tizzy, if you will, if they should happen to inhale something?
I think that I think complaints about odor are one thing that we have seen. And so it doesn't necessarily fit in with one of those criteria pollutants. But ozone is probably the one that we have the most research and understanding of, and that's the one that the Houston area doesn't meet the health-based standard for. And so the other ones, we do meet the health-based standards in the Houston area. So ozone is definitely the pollutant of concern.
We actually have a question coming in our chat, if you don't mind that I ask. So there's asking, can you comment on the use of the marine heavy fuel by ships in port having any kind of a negative impact on air quality? So should diesel use be obligatory in the port?
Well, I don't have the specifics with me, but I know that when large ships are coming into state waters, they do have to switch fuels to a cleaner fuel, and there a lot of it's worried about sulfur dioxide, and so the fuel should be much cleaner. That standard has really improved the sulfur dioxide emissions coming from ships. That's always a source of emissions for us, and that is one that we've been actively trying to research more. And each of these large ships has a transponder on them, and so we're using that specific location data every 5 minutes to then try and calculate emissions for every one of those ships over time. And so we're gaining more information about them and understanding, but overall that their emissions have come down, especially in terms of sulfur dioxide.
All right, and there's maybe time for one more question. And David, obviously you're more local, right? And Doug, you're from Houston. I'm not too familiar with the Discovery AQ campaign. Is that a local Houston thing?
That was a campaign that happened in 2013
Okay.
that the TCEQ is involved in, and NASA was the main lead with that. And they had we had a couple aircraft that were there to monitor air quality, and a lot of investigation of how air quality or how ozone is formed, and comparing to satellite measurements.
So the question, was TCEQ able to enact any immediate measures to mitigate, I guess, high ozone concentrations in the short term?
In the short term, there was not immediate, I guess if someone's asking about specific emission reductions directly after that campaign, no, a lot of this takes some significant time to understand and keep things, I guess, progressing, but there were not specific emission reductions from that.
All right, well, Doug, thank you very much for that very informative presentation there. And of course, you'll stick around. We might have some other things to ask you here in just a moment. Time now for our interactive poll questions. Let's get to that right now and see what we have here. So question number one, Congress established much of the basic structure of the Clean Air Act in what year? A, 1952, B, 1970, C, 1986, or D, 2001. So go ahead and test your knowledge, and we'll talk about the results here in just a moment. Question number two, what percentage of the world population is breathing in polluted air every day? That's a good one. A, 22%, B, 47%, C, 73%, and D, 91%. So that sounds like a bit of a trick question there, if you ask me. And then third question, what organizations have teamed up with NASA in an effort to improve air quality forecasting through collecting air quality samples and whatnot? So the three answers for that are India Space Research Organization, the European Space Agency, and South Korea Aerospace Research Institute, or C, Canada Space Agency, and CNES. So those are the three interactive poll questions that we have for you at this time. So Tiffany, are you able to follow, you know?
I am trying.
Who's answered these questions and what kind of feedback we might be getting there?
These are some tough questions, first of all, for me anyways. As you know, I am not the expert here. So David, I'm going to rely on you to explain these answers when they come up. And our tech guru, Eric, behind the scenes, he's going to work on formulating the answers for us, or at least I should say the audience answers. So we have to test our audience first, and we'll see what they see or what they think.
Yeah, and let me reread question number 3 to give you the entire question. Which organizations have teamed up with NASA in an effort to improve air quality forecasting through collecting hourly satellite observations? So that's a very good question there. And I'm just trying to cover up, Tiffany, I can see the answers here, but I'm trying to cover up and answer this myself. And these are somewhat tough.
Okay.
I tell you, let's see, Congress established much of the basic structure of the Clean Air Act in what year? I mean, I would guess 1970, but I mean, that's just me.
Are you giving hints?
Not necessarily hint. I'm trying to, you know, I would hate to ask people to do this and I'm not doing it myself. So without knowing the actual answers. Okay, so let's see. If we're there, let's see the results. Let's see what we came up with. And hopefully most of us did answer, did at least attempt to answer the questions.
So let's see. They should be posting. There they are.
Wow. Okay, so to question number 1, most people said 1970. That was my guess as well. And let's see. Yeah, the correct answer is B, 1970. The Clean Air Act was signed by President Richard Nixon on December 31st, 1970, to foster the growth of a strong American economy and industry while improving human health and the environment. So Richard Nixon signed that act into law there. And I'm pretty sure Ralph Nader's name probably creeps up in there some sort of way. I have a little experience in the automotive industry, so that name has come up quite a few times in dealing with that. For question number 2, the answer is D, okay? As far as the question number 2, what percentage of the world population is breathing in polluted air every day? And let's see, what did most people say? Yeah, most people said C, 73%, it appears. So the correct answer, believe it or not, is D.
That's kind of scary, isn't it? Yeah.
It really is, yeah. Okay, and to question 3, okay, the correct answer to that one is B. So let me scroll down here and take a look at that myself. What would I have guessed? Would I have guessed? Yeah, I probably would have come up with that one. What about you, Tiffany?
I would have also. Yes.
And our audience is very smart.
That's right.
Come up with the right answer. So looks like we are right on target with that one. Okay, so that does it for our interactive questions there. Let's move on to our next speaker. Her name is Laura Judd. Okay, Laura is a research physical scientist from NASA Langley Research Center in Hampton, Virginia. She also dedicates part of her time serving as an associate program manager for the Health and Air Quality Applications program at NASA. Laura earned her bachelor's degree in meteorology from the University of Nebraska-Lincoln in 2012 and a PhD in atmospheric science from the University of Houston in 2016. Laura is passionate about learning how ground-based airborne and satellite measurements can help us better understand pollution events during field studies, including one she co-led in Houston called Tracer AQ in September of 2021. Hello, Laura. Welcome to the program this evening. You spent some time here in Houston, and I tell you, I suppose I didn't know that the sensing, the remote sensing of what is happening with our air quality was being done, not just with ground level sensors, but with other types of sensors. Tell me a little bit more about that.
Oh, for sure. And this presentation will tell you a lot about it. But yes, remote sensing of air quality, we do it from satellites. I mean, we're NASA, and NASA has a large Earth science division. So we have a lot of satellites looking down on Earth every day. And aircraft. I've actually have been a part of some of the missions that Doug mentioned with aircraft flying around to remotely sense the air quality. And when we're talking about remote sensing, we're using sunlight or light in general to be able to get at to be able to measure the air quality components in space. So I'd love to tell you about it. So let me go ahead and pull up my slides and I can get started. And can you see my title slide?
We can see it.
All right, great. Thanks, David. And thanks for that kind introduction. So good evening, everyone. I appreciate the chance to talk to you all today, a little bit about air quality work at NASA. And so getting at David's question, I actually titled my presentation A Bird's Eye View on Air Pollution, because much of what I do is working with data from a bird's eye perspective that we've collected from aircraft and satellites. And that's what I want to share with you today. So given the short time of this presentation, I will focus on one aspect of our air quality and air pollution. So Doug talked a lot about ozone. I'm going to talk about an ingredient for ozone, or we call it a precursor, but it's needed in order to create ground level ozone. And this is related to the human influence fingerprints that we can see from space through the emissions from the burning of fossil fuels. And the indicator that we use from a satellite perspective often with this is nitrogen dioxide, which I will refer to as NO2 throughout most of this presentation. So the video here seems to be frozen, but okay, is a global map of NO2 that was collected by the Ozone Monitoring Instrument, or OMI, which is on board NASA's AURA satellite. And this is data collected between the summer 2017 through summer 2018. There are some transient hotspots that you can see, such as in Africa or in the boreal forest in Russia and Canada, which is related to the seasonality of fires. But what stands out more are the consistent hotspots around the world that are fixed in space, which is really an indicator of where people live in urban areas. So like I said, nitrogen dioxide is emitted through the burning of fossil fuels. So you can think of cars, trucks, power plants, and industry. And this gas only exists in the atmosphere for a few hours when emitted near the surface, as it's highly reactive with other gases and with sunlight, resulting in very low backgrounds beyond very low values where there are no emissions, and distinct spatial patterns mimicking emission patterns around a region. So why should we care about NO2? It is regulated by the Clean Air Act, as Doug described in his talk, but in reality, it's more indirectly controlled in the US through the ozone and particulate matter air quality standards, as it is an ingredient necessary for the formation of these pollutants. But there are studies out there that show that exposure to NO2 pollution itself or pollution from common sources can lead to exacerbation of respiratory diseases, and has even been linked to the development of millions of pediatric cases of asthma annually. So how do we measure NO2 from a satellite? This graphic shows how NASA's AURA satellite with OMI on board observes around the globe once per day. It is in what is called a sun synchronous orbit. So it goes around orbit in a fixed plane every 90 minutes or so. And what it sees as Earth rotates underneath is a view. And that's how we get our global coverage each day. I use the example of OMI here in this graphic, which has been our workhorse for these measurements since 2004, so almost 2 decades. But I will also mention and show data from the TROPE OMI instrument today, which launched in 2017. And it observes in the same manner, but at a finer spatial resolution. Okay, so we orbit Earth from hundreds of miles up with these satellites, but how do we actually measure the pollution when we're not even in our atmosphere? So if you've ever been to a populated city, the city pictured here is Houston, if you recognize the city. This is a picture that I took from the University of Houston back in 2013. And what you see in these cities often is a dense rusty brown layer near the surface, often in the morning time. And what gives that smoggy layer its brown hue isn't necessarily like dirt or dust, but it is the NO2 trace gas that is there that actually reflects in if you think of the sunlight and break apart all the wavelengths with a prism and you get the rainbow, in the red wavelengths, it reflects in that, giving it that brown red color. But what we actually measure from a satellite is in the blue parts of the wavelengths, NO2 has a very specific fingerprint. And that is what we were able to measure. So satellite sensors like OMI and TROPE OMI measure sunlight that travels through the atmosphere and it bounces off the ground and off our atmosphere back up to these satellite sensors, allowing us to measure the amount of that pollutant between the surface and the top of the atmosphere. And we call this a column density or just an NO2 column. So to share some big picture views of satellite NO2 data over time, this video shows the shift to cleaner air from 2005 to 2019 over the United States. In this time, NO2 has decreased in most areas of the country due to the implementation of state and federal regulations to reduce emissions from power plants and cars. Part of the success story that Doug was talking about in his presentation. So largely what you see in this video are these the hot spots, so the urban areas, the cities, shrinking in over time. And I point out Houston here, where in 1 decade from 2005 to 2016, the satellite was able to see a 40% drop in NO2 values. More recently, and I believe this was brought up in the questions a little bit ago, the shutdowns related to COVID-19. So you may have seen some of this data in the media talking about how these shutdowns have resulted in drastically improved air quality. The improvements, the most distinct improvement that I've seen is really related to these measurements of NO2. So this is just an example map of Southern California showing the before and after shutdown in spring 2020, showing a dramatic drop in NO2 related to less cars being on the road. So what this provided researchers and scientists is a natural experiment, or semi-natural, I guess, but an experiment no less to see how less car emissions, so if we had cleaner technology to decrease emissions from cars, how would that impact air quality? All right, so the images I've shared have been beautiful and can tell a great story, but there are some challenges to using satellite data that I wanted to share with you all. And I will talk about 2 of them today, which are I think are the 2 biggest ones in relation to NO2 measurements. So weather satellites can measure as quickly as every minute currently. So you can think of images, many of you might have seen last week or the week before when the Tonga volcano erupted. in the Pacific. And you saw these unreal images of this explosion that when I first saw it, I genuinely thought it wasn't real, but it was. And it's because we can get that repeated measurements close in time as fast as every minute. And so, but current satellites that measure NO2 or air quality like OMI and TROPOMI, they only measure once per day. And they measure in the early afternoon. And in many areas of the country, this is actually the time of day when emissions are at their lowest. Often that's not rush hour in the morning when a lot of us are driving on the road, or in the evening. However, our view of air pollution from space is changing in the very near future, which is quite exciting. As a year from now, NASA will actually launch its first geostationary satellite. I'm throwing that term out there, but I'll tell you what it means in a second. The first geostationary satellite measuring air quality over North America. So geostationary means it orbits Earth at the same rate as Earth rotates. So really what that means is that the satellite is always over the top of the same area. So it is always going to be staring at North America through all times of day. So this mission is called TEMPO. It stands for Tropospheric Emissions Monitoring of Pollution, and it is dedicated to measuring the air we breathe every hour during the daytime over much of North America to better understand air quality challenges such as those from urban emissions or biomass burning and their links to our health and well-being. This mission is part of a growing constellation of similar missions with GEMS, which was launched by South Korea and is operating over Southeast Asia since 2020, and Sentinel-4, which will be launched by ESA and operate over Europe and Northern Africa soon after TEMPO's launch. And this is part of the partnership that was alluded to in our last poll question today. So as you can imagine, this is a new territory even for air quality experts, as these measurements have never existed before. And this is really where the guts of what I think about work-wise from day to day, working with folks like Doug in the air quality community to prepare for and learn how best to use these new observations. And so I kind of want to show you what that might look like here. And I'll start by the current view. We're going to be looking at images over two major cities that some of you are probably familiar with. So on the left, we have Los Angeles, and on the right, we have New York. And those are the two biggest NO2 hotspots in the US right now. So the top map shows satellite data that is averaged over 1 year. When you compare that to an image that is collected from a single measurement over these cities on a single day, you can see that the annual average on top is smoother, with the data from the singular day, the single measurement is more pixelated. A single observation from this satellite at best is about 3.5 by 2 miles, and often it is actually bigger. However, these day-to-day, rather than using day-to-day data, tells you a little bit more about the variability in the shape and the amount of NO2 in these cities from day to day. And in fact, there's a lot of variance in this data from hour to hour, which is what we're going to see with TEMPO and what I have seen with aircraft measurements. So these are collected airborne measurements in LA and New York City. And we've collected this data in about 7 or 8 cities around the US in the last decade during air quality field studies. We repeat these measurements morning, midday, and afternoon, and measure at a spatial scale of around a city block. That was like the closest size I could think of that it would compare to. These two examples here are LA and New York. New York is actually collected on the same day as the satellite imagery right above it. And in both of these, you can visualize where the emissions are coming from, as well as the influence of our weather in transporting this pollution across these areas. So while the TEMPO measurement won't achieve the city block scale that we're seeing with these aircraft measurements, it will have a finer spatial resolution than the current satellites like TROPOMI. And it will have this time of day aspect, allowing us to see pollution events unfold across its view. So on to our second challenge is that satellite NO2 data is not a one-size-fits-all solution for everything. The measurements are only the amount between the surface and the top of the atmosphere, as I said before. I called it the column density or NO2 column. Though in general, NO2 does peak near the surface, near where we breathe, and does seem to correlate with the regulatory monitors at many times. But it doesn't necessarily have a one-to-one agreement matching in its spatial and time patterns of the air that we breathe at nose level. So this creates a challenge in having air quality managers actually use this data to understand what we're actually breathing on the ground. So the best routes for navigating toward a better air quality comes from an observing system that uses multiple points of view, like what is shown here. Each has their own benefits and disbenefits, but together they paint a more confident and complete story. I talked at length about satellite data today, and they have challenges in terms of time coverage and being only able to see what's in that vertical column. But they fill gaps where routine monitors do not exist. Routine monitoring networks run by the EPA, state agencies like TCEQ, and even citizen scientists measure right at the nose level and at our respective locations. So if you're near one of these monitors, that's great. You're able to actually see what your air quality is that day and plan accordingly. But really, there's a lot of areas of the country that don't have this spatial, and a lot of countries around the world that don't have monitors. Research aircraft can act as a gap within these measurements. And so the video shown here depicts an aircraft that can get down as low as just a few hundred feet and extending up vertically through the atmosphere as high as planes fly. But what these planes can do is actually pull in air from the outside into instrumentation and actually measure what is in the air. And it's a connection between what the satellite sees to those ground monitoring locations. And all of these together help us inform on ever improving air quality models, closing gaps in our understanding of air pollution. This is a simplified view of what we strive to put together during our intensive field missions, such as the TRACER-AQ mission that was mentioned before, and that I will mention again here, which happened in Houston, Texas in September 2021. That's where many of us were hoping to be, and we spent a lot of time there this fall. But really, the success of this data collected during the study would not have even been possible without our partnerships in the air quality community, including TCEQ, where they were essential for incorporating input into our science plan. And this also included collaboration with other federal partners, academic partners locally in Texas and in other areas of the country. And it included coordination of aircraft, boats, ozone sondes, and mobile platforms, resulting in a measurement system as depicted in the graphic on the right. And that should advance the understanding of pollution formation in its current state for Houston for years to come. It's really too early to give a lot of concrete results of this mission yet, since we just got out of the field. But I thought I would just highlight on just a couple. One aspect that challenges air quality management, not only in Houston, but in many areas of the country, many urban coastal areas, is that air quality models often forecast high ozone over the water. And there are no regulatory monitors out over the water for understandable logistical reasons, you know? And during TRACER-AQ, TCEQ, University of Houston, and St. Edward's University were able to deploy 3 boats in Galveston Bay and the Gulf of Mexico, measuring ozone at the surface and vertically through the atmosphere. So these measurements will motivate future research to determine how well air quality models are capturing this high ozone and whether it's realistic, and how do these states address that source of pollution. And then this is just my final slide showing data, but one of our other science goals during TRACER-AQ is to update some analysis on air emission inequality in the Houston area. And work led by Angelique Dematillo from University of Virginia, she found using airborne and satellite data that NO2 pollution is actually 37% higher for non-white and Hispanics living in low-income neighborhoods than whites living in high-income neighborhoods in the Houston region. She took this a step further to demonstrate that these disparities could be cut in half if diesel emissions were reduced by 65% in the city. Satellite measurement and airborne measurements are really just now achieving the spatial and temporal resolution to be able to be a component in identifying these environmental justice issues. And while there is more and more work going on at NASA in relation to this subject now more than ever, at least specifically to TraceRAQ, Angelique and others are hoping to expand these results, looking at more times a day as well as other pollutants. So I'll wrap up here with just a final thought that I hope these satellite images that I shared today at least showed you a new perspective of our imprint on the air that we breathe. I put a couple links here at the bottom, and I'm happy to put them in the chat, but one is airnow.gov, which I find to be the easiest and clearest resource to see what current air quality is, and loads of information about air pollution and the Clean Air Act in general. But also, if I piqued your interest in NASA satellite data, NASA has the RSET program, which has a number of free online trainings for users from beginners all the way up to advanced users. And with that, I thank you for your attention tonight.
All right, Laura, thank you very much. I guess we're getting on close to the end of our program this evening, but I want to check with Tiffany to see if there were any questions in the chat.
Yeah, I don't see any. If we had time maybe for one burning question, if anyone in our audience had, something that they really wanted to ask Laura, if you wanted to put it in the chat, go for it, because we are running close to the end of our program. But of course, we'll give our listeners that opportunity to ask.
Because if you don't ask, I will. I've got one, actually. I can ask.
All right, go ahead then, David.
Laura, you showed that national map with all the hot spots of the nitrogen dioxide, and you had those little dots over Houston and over Dallas and a bigger dot over LA. But I was taken aback by the Midwest, from Indiana all the way east through Ohio and into Pennsylvania and places like that. There was a near continuous coverage of nitrogen dioxide. What do you account? How do you account for that?
So from my understanding is that area is an area that has a lot of power generation facilities, or had them at least, and through regulation of NOx emission, or so nitrogen oxide emissions from these power plants, those emissions have decreased dramatically in the last couple of decades, and that's really my takeaway from seeing those differences there. And so now we're more seeing cities than that broad area of high nitrogen oxides.
Okay, Tiffany, anything?
No, I think that's all. So if you have any closing remarks, David, and thank you, Laura.
Well, I just want to thank Laura and Doug for being with us this evening and answering everybody's questions. A lot of people are really affected by just the everyday pollutants that might occur in a city like Houston and any other, all the big cities across the country. And I think it was a really good educational opportunity that we got this evening. We literally have, about a minute to go. If anyone has a quick something they want to say to the audience.
Yeah, so then I'll wrap it up. I'll watch the chat. But David, thanks so much for guest hosting our program tonight. I've enjoyed working with you. I know that our audience has enjoyed hearing your science connections to tonight's topics. And before we officially wrap up, I'd just like to point out that there's a link that was just typed into the chat box. So this link is a survey about tonight, and it's going to help us direct how we plan the Sciences for Everyone series in the future. So the link will also be emailed to you, but we'd really appreciate if you would complete the survey right after we end the webinar this evening. If you're an educator, please indicate that fact on the survey so that you're going to receive a professional development certificate that you can use towards your professional development hours. On behalf of the AMS president and the AMS Board on Outreach and Informal Education, I would just like to thank our guest host, David Tillman, of course, our presenters, Doug Boyer and also Laura Judd. And then our AMS tech person, Eric Wilkie, thank you so much. Our AMS Board on Outreach and Informal Education Chair, Vicki Gorman, who spent a tremendous amount of time arranging all of the different aspects over the last 3 nights. This event would not have taken place if it wasn't for her dedication and hard work. Of course, the City of Houston for being our host city. And last but certainly not least, our wonderful audience. We hope that you have enjoyed our program and that you've learned something new. We invite you to continue to participate in the AMS Sciences for Everyone series. Later this year, we will send out details about future educational opportunities. In the meantime, if you have any questions or if you would like to become involved in Sciences for Everyone, please email our board chair, Vicki Gorman, at gormanams@aol.com, and it's right there on the slide. I've truly enjoyed spending this evening with you all. I'll see you all next time.
Bye-bye.